Hello students, good time to all. And Chandan Kumar Pradhan. Welcome to your YouTube channel Chandan Physics. In this video, we are going to discuss Brewster's law. Let's begin. Brewster's law you have already known in your intermediate level as you studied the chapter named as polarization of light by reflection. Here we discuss how that Brewster's law is originated from that of electromagnetic theory. Let us consider the interface that separating two media, medium 1, another medium 2. Medium 1 has its refractive index N1, medium 2 has its refractive index N2. That one is the interface which is separate the two media. That is the normal drawn to that of interface. Let us consider an unpolarized electromagnetic wave. Unpolarized electromagnetic wave incident at that of interface with separating these two media. And the incident wave which is unpolarized. Electromagnetic waves. What is unpolarized electromagnetic wave? Here it consists of electric field as well as magnetic field, but we discuss by taking only electric field. Why? There will be a relation in between electric field and magnetic field, as the amplitude of electric field is equal to c times that of amplitude of magnetic field. What is c? C is the velocity of light, as that expression indicates the influence of that electric field is too high over that of magnetic field. That's why for this consideration we only take that electric field component, but no doubt there will be magnetic field. As we consider that unpolarized electromagnetic waves, so here electric field components are in the directions like perpendicular to that of plane of incidence as well as parallel to that of plane of incidence. In this figure I say this way, as it is parallel to that of plane of incidence, and dot line perpendicular to that of plane of incidence. This is the electric field component. One perpendicular to that of plane of incidence, another parallel to that of plane of incidence. This is nothing but unpolarized electromagnetic waves. Unpolarized electromagnetic waves, where is the perpendicular as well as parallel components of electric field. Now we get polarized electric field from that of unpolarized electric field by reflection at that of interface. We obtain the reflected wave, that is K R vector, transmitted wave, propagation of the transmitted wave K T vector. It creates an angle, that is angle of incidence theta I, angle of reflection theta r, and angle of transmission theta t. So how we get polarized electromagnetic waves from that of unpolarized electromagnetic waves? By reflection. From Fresnel's formula, in Fresnel's formula, it's a formula that is the amplitude of reflected wave to that of amplitude of incident wave for that of electric field component when that is parallel to the plane of incident is equal to, the expression was epsilon 2 mu 2 under root cos theta I minus epsilon 1 mu 1 under root cos theta t divided by epsilon 1 mu 1 under root cos theta t plus epsilon 2 mu 2 under root cos theta I. That expression we have already derived. Here we change that expression under the condition, we use a condition as for non-magnetic medium, non-magnetic medium, the permittivity, the permeability of medium 1 is equal to the permeability of medium 2, which is nothing but permeability of that of free space. Okay. Using that relation here, epsilon 2 mu naught under root cos theta I minus epsilon 1 mu naught under root cos theta t divided by epsilon 1 mu naught under root cos theta t plus epsilon 2 mu naught under root cos theta I. Again from the concept of refractive index, how that refractive index we showcase. First we write that expressions. Taken as equation number 1. From the concept of refractive index, as the refractive index of that medium 1 n1 is expressed as under root of the relative permittivity of that medium 1 into the relative permeability of that medium 1. So, what is relative permittivity of that of medium 1? That is permittivity, of that medium 1 to that of permittivity of that of free space, epsilon naught. Again, permeability of that medium 1, to permeability of free space is under root. As we say, under that condition, for non-magnetic medium, mu 1 is equal to epsilon naught. So, epsilon naught divided by epsilon naught into mu 1, here mu 1 is equal to epsilon naught. In mu 1 we use epsilon naught, that is epsilon 1 mu naught under root is equal to epsilon 1 divided by epsilon naught under root. Is the value of n1, permittivity of that medium 1 in terms of refractive index, refractive index in terms of permittivity. Similarly, n2 relative permittivity medium 2, relative permeability medium 2 under root epsilon 2 epsilon naught mu 2 mu naught, as mu 2 is equal to mu naught divided by mu naught, we obtain epsilon 2 epsilon naught under root refractive index in terms of permittivity. So that here n2 divided by n1, that is epsilon 2 epsilon naught under root divided by epsilon 1 epsilon naught under root. That is why n2 divided by n1 is equal to epsilon 2 epsilon 1 under root. Let that one as equation number 2. Therefore, equation 1 now changed to equation 1 changed to E over E y parallel situation. In place of epsilon 2 by mu naught, use n2, that is n2 cos theta I minus epsilon 1 mu naught n1 cos theta t divided by n1 cos theta t plus n2 cos theta I. In that of numerator side, denominator side, let we divide n1. So we obtain n2 by n1 cos theta I minus cos theta t divided by, when we divide by n1, so that term written in first as n2 divided by n1 cos theta I plus cos theta t. Okay. Here we use Snell's law. From Snell's law, when we apply Snell's law, how anybody can apply Snell's law? That is the refractive index into sine of the angle of incidence. Refractive index sine of the angle of incidence is equal to refractive index sine of the angle of that n2 sine of angle of theta t. Here we obtain n2 by n1 is equal to sine theta I divided by sine theta t. In place of n2 by n1 we substitute that value, sine theta I sine theta t into cos theta I minus cos theta t divided by sine theta I sine theta t cos theta I minus cos theta t. Taking the LCM, and in that of numerator to that of denominator side, sin theta t cancelled. So we obtain sin theta I cos theta I minus sin theta t cos theta t divided by sin theta I cos theta I minus sin theta t, so that is plus sin theta t into cos theta t. For our convenient, we multiply and divide 2 on that of numerator and denominator side. So 2 sin theta I cos theta I minus 2 sin theta t cos theta t divided by 2 sin theta I cos theta I plus 2 sin theta t cos theta t. 2 sin A into cos A, that is sin 2A, sin 2 theta I minus again that relation sin 2 theta t divided by here sin 2 theta I plus sin 2 theta t. Come to another page. Is equal to sin A minus sin B. What is the relation? 2 cos A plus B by 2 into sin A minus B by 2. 2 cos A plus B by 2, A plus B by 2, that is 2 theta I plus theta t divided by 2 into sin 2 theta I minus theta t divided by 2 whole divided by sin A plus sin B, 2 sin A plus B by 2 into cos A minus B by 2, 2 sin theta I theta t divided by 2 into cos 2 theta I minus theta t divided by 2, which is equal to 2 to cancel out, cos theta I plus theta t into sin theta I minus theta t divided by sin theta I plus theta t divided by cos theta I minus theta t. Here sin theta I minus theta t divided by cos theta I minus theta t. Here cos by sin as cot theta I plus theta t. Here sin by cos, that is tan theta I minus theta t. Here that cot can be changed to tan as tan theta I minus theta t divided by tan theta I plus theta t. What is that one? That is the amplitude of the ratios EOR to that of EOI when that electric field vector is parallel to that of plane of incident. That one as equation number 3. This is an important equation. Look that equation. When we put theta I plus theta t is equal to pi by 2, if theta I plus theta t is equal to pi by 2, then tan of theta I plus theta t, that is tan of pi by 2, which is infinity. Tan pi by 2 undefined. Therefore, EOR EOI under that of parallel will be 0. What exactly that expression indicates? That is, the reflection coefficient is 0. The reflection coefficient is 0, means there will be no reflected beam, which means there will be no reflected beam and no energy carried by the reflected ray, no energy carried by that of reflected ray. That's why that results if an unpolarized beam is incident at an angle theta I plus theta t is equal to pi by 2, then what we obtain? Then the parallel component of electric field vector, the parallel component of electric field vector that is E vector parallel will not be reflected, will not be reflected. Such that not be reflected means the reflected light will be polarized with its E vector perpendicular to the plane of incidence, perpendicular to the plane of incidence. This is known as BREWSTER'S law. BREWSTER'S law. And the angle of such incidence, is called BREWSTER'S angle. BREWSTER'S angle, that is BREWSTER'S law and BREWSTER'S angle. Let me understand it. BREWSTER'S angle, or we can say angle of polarization, it is polarizing angle. Polarizing angle given by theta p. Come to our figure. This is unpolarized electromagnetic waves. From that of mathematical expression, it clear that when that electric field vector is perpendicular to the plane of incidence, under that condition, when the angle of theta I plus theta t is equal to pi by 2, then what we obtained? If the angle in between theta I plus theta t is equal to pi by 2, then what we obtained? There will be no component of that of reflection. The reflection coefficient is 0, which means there will be no reflected beam and no energy carried by that of reflected ray. That is the reflected ray. In that of reflected ray, there will be no such component of electric field that is parallel to that of plane of incidence, but the electric field which are perpendicular to that of plane of incidence are obtained. If an unpolarized beam is incident at an angle of theta I plus theta t is equal to pi by 2, then the parallel component of electric field vector will not be reflected, such that the reflected light will be polarized with its E vector perpendicular to the plane of incidence, and this is nothing but BREWSTER'S law, and the angle of such incidence is called BREWSTER'S angle or polarizing angle. So, here at that of reflected wave we obtain the component of that of electric field which are perpendicular to that plane of incidence. Here we obtain the polarized electromagnetic waves, that is polarized EM waves. But at that of transmission, the wave is unpolarized, that is partially polarized, or we call it as unpolarized. Now, we obtain polarized electromagnetic waves from that of unpolarized electromagnetic waves under that reflection condition. Mathematically, we shown it, that is BREWSTER'S angle and polarizing angle. Therefore, writing that theta p polarizing angle plus theta t is equal to pi by 2. That is why theta t is equal to pi by 2 minus theta p. Using Snell's law, what is Snell's law? Sin theta I by sin theta t is equal to n2 by n1. Sin theta I, sin theta t, n2 by n1, Snell's law at refraction. Sin theta I is nothing but theta p, that is sin theta I. Here we obtain, that is theta b polarizing angle or BREWSTER'S angle. In place of sin theta I, sin theta p divided by sin, in place of theta t, that is pi by 2 minus theta p is equal to n2 by n1 is equal to sin theta p divided by sin pi by 2 minus theta cos theta p is equal to n2 by n1. Therefore, tan theta p is equal to n2 by n1. From that expression, theta p is equal to tan inverse n2 by n1. Here theta p is the BREWSTER'S angle or polarizing angle, which represents BREWSTER'S law. From that expression, we calculated what be the angle of incidence for that particular electromagnetic waves. We have to taken the polarized electromagnetic wave from that of unpolarized electromagnetic wave under the condition of reflection, that is the tan inverse refractive index of that medium to that of refractive index of another medium. Then what be the angle? That is nothing but polarizing angle. If we incident that electromagnetic wave at this polarizing angle, then we obtain polarizing electromagnetic waves from that of unpolarized electromagnetic wave. This is the BREWSTER'S angle, and that is the origin of BREWSTER'S angle as we studied in your intermediate chapter named as polarization of light by reflection, polarization of light by reflection. As electromagnetic wave, light is an electromagnetic wave. Since it is valid for electromagnetic waves, then it is valid for that of light also. So here with the help of this video lecture we understand the concept of BREWSTER'S law. We proceed from that of Fresnel's formula. When electric field vector is parallel to that of plane of incidence, this is the first Fresnel's equation. Refractive index formula is used, and simplifying that one, we obtain this. From that of expression, when we put that equal to pi by 2, so that value will be 0, what it signifies. And finally we show this is the BREWSTER'S law, and the angle of such incidence to obtain polarized electromagnetic waves from that of unpolarized electromagnetic wave by reflection is called as BREWSTER'S angle or polarizing angle. What is that BREWSTER'S angle? This one is the BREWSTER'S angle. That figure clarifies how we obtain polarized electromagnetic waves from that of unpolarized electromagnetic waves under that reflection condition, and the idea of BREWSTER'S law and BREWSTER'S angle. So, with this useful and informative notes, let me wind up the session. Thank you.